Okay, I just started recording. Okay, are we good to go? I need some confirmations, otherwise it will be difficult. Okay, so let's just assume that most of you have opened it. For those or those of you who haven't, I'll just say that I'm recording this session. So okay, so you can do this later on as well. I have shared the notebook. I'll share the other notebooks as well as we will need it. So for now, focus here. Let's get started. So what are we gonna do today? To start with, before we do anything, the first and the most important thing that I said in the starting of the previous session, and I will say it again because it is something to remember. What are we doing and what are we not doing? Does anyone remember from the previous session? What are we doing and what are we not doing? We are doing astronomy, and what are we not doing?
Astrology.
Exactly. So keep this in mind. It's very important. Now, what will we do today? Yesterday, not yesterday, actually, the previous session, we saw what exoplanets are. We studied a bit about them. And then we went on to see the use of data in astronomy and how astronomy is uh, specifically a data science, as in the amount of data that we have, the use of data that we do. We saw that, but we never did it. So why do trust someone just because he said that it works? We'll just see when I say data, what I actually mean and how does it look like. So before going into using that particular data, it's very important to learn that where are we getting like data from? Because first step is getting data from somewhere, and the second step is using that data. So as we saw in the exoplanets part in the previous slide, there are lots and lots of missions that we have. There are lots of ground-based missions as well as space-based missions. So these are the missions that are collecting data all the time. That's what their job is. And then when you collect data, you have like two options. The first option is, for storing data, you have two options. The first option is to store data in flat files. Now, what does flat files mean? Have you guys ever heard of the term flat files? Yeah, no, anything? Okay, might not have heard of the term, but obviously every one of us knows flat files. We have all used what flat files usually are. Flat files are files like .csv file and .dat file, all kinds of file that we use to store data, or like .txt file are known as flat files. So it is one of the ways by which you can, for example, your Excel file is a flat file. In your Excel file, you can create a sort of a table like something, or you can name your columns and just put in numbers in that. That is how you collect data and you store it there. And then the other way of collecting data is using a database. And I'm pretty sure you must have heard of the term database before. So it's usually a debate which is better, storing data in a database or a flat file. It depends upon your use. But if you have a huge, like lots of data, that's when using database is more helpful, because querying as in getting data from a database is much more easier than getting it from like flat files like CSV or whatever we use like. So today we will go through two of the very famous databases that are, there are lots of databases by the way. We'll go through two databases that are used. The first one is the famous Gaia mission, and the Gaia mission which led to the creation of Gaia database, and we'll see what exactly it is. And the second one will be NASA Exoplanet Archive. So are we good to go? I think we are. So let's get started. So on your screen, as you can see, okay, so before doing any sort of Python, Or so also yeah, I would like to mention that we are using Python for this. I mean, it must have been fairly evident by now, but yeah, it's good to always mention. Before using anything, before getting into anything, we are just importing some of the important libraries that we will be using throughout the session. We can do it later as well, but it's good to do it before because it will be used everywhere. So, and I'm hoping you have like learned all these libraries that we are going to use. You must have read NumPy, Pandas, Matplotlib. I think I did cover all these. And again, I would like to repeat that if you have any doubt, feel free to interrupt me whenever you want to. Or if you feel like there's something which I'm assuming you know, and if you don't know, again, feel free to interrupt me because I can cover it like in a very short time. So given that we know this, let's get to Gaia. Now, what is Gaia? Yeah, the image that you see is of the Gaia mission. So you can read about what Gaia is. I mentioned this here, that mission led by European Space Agency to collect data. So the basic purpose of Gaia mission was to actually create the perfect image of our Milky Way galaxy. So the image that you see, I mean, it's obviously like the image that you see, you're not getting much data from it because it is a JPG image, but that is kind of, I'm trying to represent Gaia in a way that you can see this Gaia satellite here, and then you can see like the Milky Way. So that's what its purpose is. Now, what does Gaia have? The data that Gaia has, we will go to, I mean, we'll go to the exact actual database and see how does it actually work. But before that, it's important to know some of the stuff. So the Jupyter notebook that you have opened in your screen is important, but more important would be to focus on it and go on that particular database, because in the notebook we are using some of the data sets that you can see here, two CSV files I have used, and that is something which I have not shared with you because you will have to download that particular thing like yourself. Okay, so some of the definitions that we should know before going ahead. What will Gaia have? So usually Gaia data has certain objects that it sees inside Milky Way galaxy and some of the properties of that particular object. What are the properties that Gaia has? These are the properties: right ascension, declination, radial velocity, parallax, proper motion. And since you have the notebook, you can read these in detail, because if I go into the detailed definition of all these things, it will take lots of time. Just a minute. So I'll cover very like simply what these is. Have you guys read about coordinate systems? Any coordinate system, Cartesian coordinates, spherical coordinates, anything? Okay. So you guys know about coordinate systems. So in order to describe the location of a particular object, you need two quantities, two numbers in a 2D space. Since you're living in 3D space, we do need like 3D representation of, I mean, to exactly specify where a particular object is. But if you assume, if you like, have you learned spherical coordinates? Yes, no,
Can you
or
just briefly tell about?
so spherical coordinates is something which again will take a bit of time. Just you can assume one thing, that just like in a flat space, you have like x-axis, y-axis, and z-axis, which are like three perpendicular axes. Similarly, in for example, on the surface of a sphere, to determine, you have how will you determine a point on the surface of a sphere? You mention that point's radial distance, which is known as r. What is the radial distance from the center of that sphere to that particular point? What is the distance, and like where is it oriented? That will give you the r coordinate, the like the radial position. And then there are two angles which are specified. Now, how are these two angles specified? It depends upon what kind of spherical coordinates are we using, and that you can read like like in this right ascension and declination are basically the two spherical coordinates and the two angular coordinates actually, because we are not concerned about radial ones. Forget about forget about spherical coordinates. You must have seen a globe, right? You must be knowing about an you must have read Atlas globe. You must have seen maps. I'm sorry. I'm hoping there's no one in this group who have never seen an like a map or an atlas or something. So what? How do we specify position of a particular place on a globe or in a map? We mentioned two numbers. What are these two numbers called? There are two numbers that specifies like the position of a place on a globe or on a map. Like I can ask anyone this question: Ki, from whichever place you are, what are the exactly as people say latitudes and longitude? So I can ask this question to anyone that from the place there where you are, what are the latitude and longitudes of that place? That will give me an exact location where you are, and it will become very easy for me to nuke your particular place. Yeah, don't worry, I'm not gonna do that. I'm not American. Yes. Right ascension and declination. What exactly these two numbers are? These are in a way these can be represented as latitudes and longitudes, but like in celestial sphere. Now I'll have to explain what a celestial sphere is. Okay, I don't think about this before speaking. Okay, you are on this planet Earth, and Earth is spherical. Again, hoping that there are no flat earthers in the this meeting. So the Earth is round. We have latitudes and longitudes to specify everything, and then you see this universe outside. So can you imagine? I mean, you don't see how radially far an object is, right? When you are seeing something in the night sky, you more or less you see them like at what angle they are. Basically, you see a 2D projection of the 3D universe, isn't it? You can imagine it that there is a big sphere, and we are inside that sphere, and at the surface of that big sphere lies all the stars and everything that you see around. Can you imagine what I'm trying to say? A big sphere, that sphere having like all the stars and everything that you see, and we are inside that sphere on a smaller sphere, which is our planet Earth, right? I hope no one's having difficulty imagining this. So the big sphere that I'm talking about is known as celestial sphere. And on celestial sphere, just like on Earth, to specify a position, you need latitudes and longitude. On celestial sphere, to specify position, you will need two numbers, which are right ascension and declination. Now, latitudes and longitudes are defined in a particular way, depending upon how the axis of Earth is tilted and like where's prime meridian, where's equator. I mean, there is a reference point. You always use a reference point to define certain angles. So just like this, for right ascension and declination, there are reference points. And again, we are not going to go into that because this will take an entire session. But of course, you can read about RA and DEC, how these are defined. As of now, you can imagine that RA and DEC are two coordinates of a particular object in the night sky. This much information is good enough for you. Radial velocity, very obvious. Everyone knows, I guess. How far, like how fast an object is moving in the radial direction. Okay. Parallax, everyone knows. And guys, if you don't know, just read about it. I've clearly written what parallax means. And then proper motion. Proper motion is just like in XYZ axis, you have like in X, if an object is moving in X, its velocity is like written as Vx. And similarly, if it is moving in Y, it is known as Vy, or like the component of its velocity in X axis is known as Vx and component in Y axis is known as Vy, right? So similarly, a proper motion refers to the velocity like of that particular object in the celestial sphere in terms of right ascension and declination. If you have studied derivatives, in a way, you can say that proper motion is the time derivative of right ascension and declination. Read about it more. I know like it's not easy to just explain this in like in this short, but we really don't have time for this. So just read about it. You have everything which is written here. Now, what we are going to do here is we will actually see the real archives. So, I mean, here you will find the link to Gaia. I'll just search here. If you like don't want to go to the link, you can just search Gaia mission or the logo. I think this is the website. No, I am on the wrong website. Yeah, this is the by European Space Agency. So this is how our Gaia archive looks like. Again, we know what is Gaia, and we know that it is a database. Since it is a database, it will contain data. Our job now is to query that data, take out that data and work with that. So how do we do that? In the Gaia archive, there is a search option where we will click. And here, what you, I mean, so these are the things that you see on your screen. So how do you search for a particular? Okay, you don't search for a particular object, you search for a particular area in Gaia archive. So Gaia, what Gaia does is that Gaia is all the time, it is like querying data from all across our Milky Way. So it just takes all this data from a particular area. That area is in terms of angles, but not important. And this is how you query data from Gaia. You can just type, like if you want data from a particular location, you can type any object which lies in that location. Like for example, I am searching for M42. What is M42? M42 is Messier 42, Messier objects. Heard about Messier objects? Anyone? Okay, I'm supposed to ask if there is anyone who doesn't know about Messier objects. I mean, there are certain things which are not important in our session per se, but I think when I'm typing something or writing something, it's important for me to make every word of it like clear what exactly they are. Otherwise, there's no point, right? So Messier objects, there was an astronomer called Charles Messier. He just saw things in the night sky, and whenever he found something interesting and different, he named it, like he didn't know what it was. So he named it as he gave like some index numbers to it, and it started people started calling it Messier and that particular number. So even our Andromeda galaxy has a Messier number. We saw Messier 87, M87 in the last session, which was this black hole. So that's how we query data from Gaia. Object is something. I'm there in the meet, right?
Yeah, you are.
Yeah, yeah.
Okay.
Okay. Sorry. Yeah. So M42, and then where exactly are we searching? We are like searching like from M42 in the center. We can see like in how big of a radius we want to search. So we are defining radius. We can write whatever numbers we want to here, and then we can just write what units we want it in, like in degrees, arc minute, or arc second. Let's say, for example, we choose arc minute. So in 5 arc minute radius, like with M32 as the center, this is the area in which we want to search what all objects there are. Secondly, where are we searching? So these are the various sources that we have. And like all these sources have like some meaning to it. Yeah, but like the recent most one is Gaia dr3 dot Gaia underscore source. This is where we are gonna search. Now, some idea about what is Gaia dr3. Dr3 means data release 3. Gaia is the name of the archive. You have to be sure that you are not using in any case, you're not using Gaia EDR3. So EDR3 would be like it's called early data release, and we don't want early data release. Whatever science is done, it's usually done on the exact data release. There is usually an early data release as well, but it's not like that verified or that clear. So we prefer using DR3. So we are use this, and if you want to put some extra condition, you put condition. What are the conditions that you put? Condition could be anything. Like these are things that you're searching for, right? So you can, if you want, you can search for stuff like I only want those uh, objects for which, let's say, array is equal to greater than less than some number. You can put condition if you want. And one more advantage that this particular database gives you is that you can filter, like if you can put 5 conditions, and then you can also specify that if all these conditions should be true, or if it's like any condition should be true. You must have read about, or and these logic gates. I mean, it's there in the school, so it's kind of like this. So if all conditions, any condition, this you can specify. And then display columns. What the columns do you want? Although like in that slide I just showed you array, deck, proper motion and stuff like this, there are these many options that you get. I mean, everything has a meaning. PM deck is like proper motion of declination, and BPRP is the color magnitude. Like each and every row has a meaning, and you column will have a meaning, and you can like choose whatever you want and like discard whatever you don't want. See, the thing is, no, in real this database has all these columns, but usually we don't want all these columns. We just want a very small part of it. So why to, you know, get all these columns when we want a very small part of it? Because when you're getting, the more columns you get, the more amount of I mean, the size of the file will increase uselessly. So you have an option to choose whatever you want. So certain things are already ticked. I am going to go with that. Source ID is important because source ID is something which okay, one important thing to realize is that there's this one column which is like serial number, source ID or something, which is a unique column which specifies which object that particular thing is. So this is important. And then array deck will give us location of that particular object. PM deck will give us the velocity in that particular uh, what do we call it? Velocity in that particular direction, like in towards array direction or deck direction. Then parallax, you can find out the radial distance using parallax to a particular object. Because when we are using array and deck, we are specifying just 2 coordinates, but there's always a third coordinate. Although I said that everything is there in the celestial sphere. Celestial sphere is just the projection of the real thing in that particular 2D space, but the actual space is 3D. So we need parallax as well. So these are things which are there, and up to you. You can choose whatever you want, whatever you don't. And then the moment you choose everything, what you can do is you can just submit your query. This is the you form the query. Invalid condition. Oh, sorry. Yeah, just to show you, I just put something random and I need to delete this. Yeah. And now you will submit your query. Once you submit it will load for a while. And then yeah, see, you get this data. So this is how a data like from a database looks like. You can just search for it, whatever you want. And I mean, you can see data here, but you really can't like work with data here, right? Because you must be having some Python code where you will work it. So you need to download this data. How will you download this data? Here you can just like choose which format you want to download in, VO table, or usually CSV is this one in which people download. But in Astronomy, we use FITS files. So FITS files is another format in which we can download the data that we have. And the advantage of there are some advantages of using FITS files over CSV files. FITS files is something which cannot be edited very easily. So it cannot be changed. CSV file is someone can open it in your it's not called FITZ, it's called FITS. It has a full form which I'm forgetting right now. I used to know it has a very good full form. Uh, Something is there which I don't remember. FITS files were originally made for storing astronomical images with all the data in there. But later on, astronomers started doing all sorts of work in FITS files. And there is a way how do you open FITS files in Python. But I think Adyut showed this to you too. Did you guys? Yeah, exactly. As someone said, that flexible image transport system. It used to be for image, but now people have started storing the data in it as well. Did Adyut cover AstroPy for you guys too? Can someone just confirm once in his Python session? Okay. Yeah, so there's a library in function in AstroPy where which helps you take get out fits file. But like, yeah, CSV is more straightforward, so we can download in CSV file. And once you click here, then you can download your result from here. And that's how this works. So seems like we are good to go. We understood what exactly how exactly Gaia archive looks like and how do you search for any particular thing in this Gaia archive, right? So till now, does anyone have any doubt? It's 11:09, almost half an hour since we started. So anyone have any doubt? I'm asking this because we are going into something very new now, something that you will like learn. A new thing that you will learn. So that's why I just want to clear like what exactly do you want? Someone has asked how to set up categories or conditions. I just showed, in basic, you have this option of adding extra condition if you want. You can add condition. I mean, what condition usually are? Conditions are usually that the columns that you have, should the values in those columns be greater than, equal to, or less than a particular value, right? So that's how you add extra conditions. I don't understand what criteria should you choose. Can you just speak up? Like I don't understand your question.
I was asking by what criteria should we choose what conditions and what columns should be added? Should we have knowledge of it beforehand, or is anything particular that we want and anything around it we should also be chosen?
Yeah, okay, so I got it. So it depends upon why you're doing work. I mean, people don't usually, go into a particular database just to learn what database is about. So, when you're doing some work, there is a purpose. Are you trying to find a distance to a particular galaxy? If yes, you can just choose a source ID and parallax. So it depends. It totally depends upon what work, what's the purpose of the work that like you want to do. That's what decides what exactly you want. Right now, what we are doing is we are just seeing like this is for the general public. Whatever work you want to do, this is something that people can do is what I am showing. But it totally depends upon your work. As I said, you can choose parallax if you want, if you're looking to find distance. For example, you don't want to find distance, you want to find this redshift. For redshift, I showed you this color, I think no BPRP. Yes. So this is the color magnitude difference. So you can choose this column if you want like this data. If you want a radial velocity for something like of a particular object, you can choose this. Your other question was that what area should we choose? So again, it depends upon which, again, say the same thing, which area of sky are you looking to probe? If like you're looking to probe a general sky, usually that's not what people do, because the more specific you want to get, the the more specific you get, the better it is. That's why you choose a center point. Like if you want to see, like for example, I'll just give you an example. You find out like some weird peculiarities, some weird signals coming from, let's say somewhere near a particular known object. So you will like search for that known object, and then you will type within what radius do you want to search for, and then like you will get all the outputs that you want. I hope that this answered your question. Naveen, I guess it is. You have. Okay, great. Any more doubts? Okay, I'm hoping not. So now we will continue. What did we see now? We saw how exactly to get data from Gaia. Now, once you have data from Gaia, we saw how to save it, and we saved it in CSV format. Now you can do any Python that you want in that. So just for an example, what we have done here is that we have downloaded the file. We have uploaded the file in Colab. When you're working with Colab, you have to upload the file in the Colab because Colab does not work in your system. So you can do this work in your system as well, but in Colab, usually you have to upload it. So we have saved the data that we've downloaded m42.csv file, and that we have uploaded here. And in this line, we can reading the particular file. For reading, we are using pandas. Again, I guess Adit covered pandas too. And after why do I use? I mean, there are many libraries that you can use to read file. You can use simple NumPy as well. NumPy has a load txt function which also reads it and stores it in NumPy array. I usually prefer to save it, use pandas because once you show the output of that particular table in pandas, no, this is how it looks like, and according to me, this looks much more beautiful, isn't it? Is there someone who will say that this doesn't look beautiful? I don't think so. It looks beautiful to me. And then pandas also it gives you the number of rows and columns that you have. Columns will tell you what all data you stored, like source ID, array, deck, palace, what all data that we stored. And rows will tell you the number of, I mean, every row is a particular object. So these are the objects that we saw. Also, one thing that you would have noticed in Gaia, when we had our query result, that certain certain cells are empty. So they are empty because we don't have anything to put in these columns as of now. And it's very possible that you might find certain object, but you might not have certain data, certain object. That's why missions just keep on happening so that you just keep on getting more and more data. So these parts are like in pandas, these are stored by NaN. NaN is something that we do not have data for yet, and we prefer not to use these. So m42.head just gave you 5 rows, but in general, there are 714 rows. There's no point in showing all the rows, right? This is just for showing that how our table looks like. Now let's do some science with it. What is the first science that we do? Human mind is much better in picking out stuff from visualized plots rather than from numbers. You can write code and pick out stuff from numbers, but it's usually good to see some plots, and it helps you just show some stuff. So that's why we will plot some of the things, and we'll see how the data that we have picked up looks like. So for that, we are using matplotlib. And we have stored the fixed size here, as in this particular line. The first line of the code will is used to specify how big that plot should look like. And then we are using a scatter plot. Scatter plot. Heard of scatter plot?
Yeah, it was shown.
Yeah. So scatter plot are the sorry. Scatter plot are the numbers. Scatter plots are the points that we plot. So we have plotted scatter plot, and what do we have? We have plotted array and deck. So this is how you query any particular. I mean, if you want to query this particular column of this table in pandas, how do you query? The name of the data. This is called as a data frame, by the way. This table is known as pandas data frame. So this data frame is named M42. So how do you query? You write M42, then in square brackets, you write the name of the column. So we are plotting array versus deck. Array versus deck is basically we are plotting the actual coordinates, x-axis and y-axis, if that helps you understand more. And then X label, Y label, and title. And this is what the data that we had. This is how it looks like when we plot it. Looks beautiful, isn't it? I mean, at least, okay, won't say beautiful, but at least it helps you visualize stuff, that how it is distributed. How certain objects are closer to Messier. The object in red is the central object, Messier 42. Now, how did I plot this in red and the rest in blue? So this line of code specified that I plotted this particular object in red. Arrow specified red and round. Now, how did I get these coordinates? I mean, since I plotted this, I had its coordinates, right? 83.82 minus 5.39. How do I got this? So in Gaia, when you search for your query, what you usually do is that there's a section called as ADQL, where it shows you like how does your query look in ADQL form. Okay, this is where it is. So when you look here, no, you will find this particular point. My screen is not lagging, right?
No, it's fine.
Okay. So when you go here, you will see the coordinates of the particular object you mentioned here. So 83.82 minus 5.39. Now, what exactly this particular box is and what are these things which are written? That's what we will see now, and that's what will help you like realize things a bit in a bit of more better way. And this is very important. So yeah, once you plotted this, we are done. And now like you have an assignment to do, which you can do later on. Now we are starting with the next part, which is more important part. When we were in Gaia, we use this basic search. Whereas we just wrote some numbers and we just typed certain stuff and found out data. Do you really think it's this easy and you can do everything that you want from this? And again, actually, this is what I wanted to answer before when Naveen asked his questions about conditions and stuff. But I didn't mention this then. But you cannot search for everything using like that particular basic search query that you have. What you usually do is you write a name, you write radius. These are like very basic things that you do, but there could be other conditions that you want to put in. That you something that is something which you don't do here. So for that, we use advanced search query. Now, how do you use advanced search query? In advanced search query, you just get a box and you have to write some stuff. What do you write? Have you heard of the term SQL ever in your life?
Search query language.
Yeah, it's I guess it's structured query language, not search query language. I never bothered to know the full form, but I think it is structured query language. Anyways, so why was SQL language invented? If you have read about SQL, sometimes it looks very simple to use. Like you use basic English statement. Now, what is okay? To start with, what is SQL? Just like Python is a language, SQL is also a language. SQL is a higher level language than Python. So why was SQL needed? SQL was needed when these databases formed. No, when you have to get something out of a database, that's when you use SQL. So yeah, that's why it was formed. And what we are doing right now, that's exactly what we are doing right now, right? We are getting data out of databases. So like that's what we will do. We are going to do SQL now. And so for people who have not studied SQL, SQL is a very, very, very easy language to learn. It's just that we cannot go deep into SQL again because of time constraint. But like I'll try to cover some very simple commands. One thing that I would like to mention here is that you cannot, you don't see SQL written anywhere on your screen, do you? What do you see written on your screen instead of SQL?
Your screen is showing the Gaia archive.
Yeah, I know. I'm seeing instead of SQL. Yeah, as someone mentioned, it's not SQL, instead of ADQL instead of SQL. So what is ADQL? I mean, all this time I talked about SQL, but here you are seeing ADQL. Actually, what we are going to do is called as ADQL, not SQL. So what is ADQL? And again, I never bothered to know the full form, but I think it is astronomical data query language. So astronomical data query language is SQL only, but a specified form of SQL. I think ADQL was developed just for Gaia. So a specified form of SQL where you write like there are some special commands, there are some special functions which is available just to help you for astronomy in particular. That's why we call it ADQL. But like the basic sense is how you work with SQL only. We have almost 25 participants in the meeting. I would just like a show of hands of how many of you don't have not studied SQL ever, anything about SQL. Okay, I see one of you raising your hand. Okay, so I'm hoping rest of you have studied SQL, somewhat SQL at least. Okay. Okay, more people now. So for people who have studied, this will be a bit helpful, but for people who haven't, I just go to some of the very simple commands. So this looks like a very complex command. Let me just clear this out. We'll start with something very simple. We'll just copy. Okay, we have not written anything here that I can copy. I wish I would have. It would have become too simple for me. Ah, yes, I have written something. I'm not writing like things from the beginning. I'll just copy this. Then paste this. Great. Yes, so one by one we'll see what this, whatever I have written, what this means. And for this, I will just arrange it in a way that it looks a bit better. Okay. Now, some of the commands that we see will go through line by line. First line says select top 200 Gaia source dot source ID and some stuff. What does this mean? This means that from the table you want to select columns. What all columns do you want to select? Again, and here you are not doing anything in the basic query. You are doing each and everything in SQL. You are just writing stuff from your hands. So when writing stuff, you have to specify everything. So for the first thing that we will specify is that what all columns do we want? So that's when you write select top 200. What does top 200 means? It means that if like the output of a particular query consists of let's say 700 or 800 objects, we don't want all of them. We just want the top 200 ones. So that's what top 200 means. And these are the name of the columns. So Gaia underscore source is like name of the particular database, and dot we usually put is that in that particular like database, which column it's Gaia dot so Gaia underscore source dot source ID. We want source ID, array error, deck error, parallax error. We are like if we need these columns. Next we specify where do we need these from. We need this from like what is the name of the database from where we need this from. What is the name of the table from where we need these from. So the name of the table will be Gaia dot source is the name of the table. Gaia DR3 is the name of the entire database. It has like lots of like tables. It has lots of stuff. So which table do we want stuff from? We want it from Gaia underscore source. You can just play with this. You can just write whatever you want and see what output it produces. And then now we have specified what are columns we want. We have specified what all do we want. Usually these two lines are enough to get a output. Now we come to next where statement. The where statement specifies the condition. Again, like Naveen asked, what conditions do we want to specify? So what conditions are we specifying? We only want those columns in which the parallax value is greater than equal to 0. We only want positive parallax, because if there is some source with negative parallax, it means there is something is wrong, right? So that this is the condition that we have specified. And the last line says order by. What does order by mean? The output that we want, the particular output would, like should be sorted. How have we sorted it? We have sorted it in terms of parallax. As in the final output, what you will see, the column parallax will be sorted. The smallest parallax will be at the top and the biggest will be at the bottom. Or will it be the other way around? How do you know if it will be like if like the smallest parallax will be at the top or the biggest parallax will be at the top? The answer is right there in front of your screen. What particular command is telling you that you know that you have to order it, but in which order are you ordering it? Anyone? There are two orders, right? You can either like writing it in increasing or decreasing order. Maximum parallax can be there or minimum. Someone has said ascending. Do we have any more answers? Okay. So I have two answers here. One is saying ascending and Anjali is saying bigger one first as in descending. So like these are the only two options possible. So it will be either ascending or descending. How do we specify this? I mean, if we are writing everything from our hands, we should be able to specify this, right? That how do we want it? So how do we specify it? There is a line or something in the code that I have written that is specifying this particular thing. Exactly, as Ganguly pointed out, it's DESC. So DESC means descending, and we are when we are writing DESC, we are specifying that the biggest parallax should be at the first, and the smallest parallax will be at the bottom. And since you have selected top 200, we have to specify in what sense, like top 200. So now we know that the table that we will get, we will have these columns that we have mentioned. We will from this particular table that we have mentioned with the condition that parallax will be positive, and we will order it in descending order, and we will just have top 200 of like output that we have mentioned. And when we have written our query, we will submit our query and we will see what we get. So your query is submitted. Now you can you see this query? Wait, you can download this query, but can you see this? Yeah, here you can download the results of your query that I mean, the table is right there. This is the table and you can just download it and start using it. There must be a yeah, display. So if I click on display, it will show how it looks like in this Gaia archive. Now, if you like, I guess it's 200. Yeah, I mean, the screen is just showing 20, but it is 200. So it is 200. We have queried source ID, RA error, deck error, parallax, and parallax error. And as you can see, the parallax errors column, it is in descending order. Maximum parallax is first, and it keeps on decreasing. So this is how you write a very basic SQL, to be honest. And in ADQL, you have more functions to do stuff, and you can keep doing stuff. Now, why do we use? I mean, okay, which is better to use according to you? You saw basic and you saw ADQL. According to you, I just want your opinion from whatever you saw, which would be easy to use. And be very honest. You don't need to be like just because something is advanced, it is better, or just because something is basic, it is like bad or something. You be very honest according to you. I just want a few opinions. What do you think is easier? Okay. For you, I'm asking in general on opinions. Like someone has said basic useful for beginners. Yeah, so as Anjali gave us one advantage that in ADQL, we can sort data. So it's actually like in basic, you're doing the same thing, but at times basic is simple to use and at times advanced is simple to use. So whenever see there are some things that you want in your data, right? So if whatever you want from your data can be done using basic, then please feel free to use basic. But basic has its limitations. And when you want to do something which is not, which cannot be done by basic, that's when you start using ADQL. And I usually prefer to use ADQL just to learn it because it's very easy to forget something if you are not practicing it. So at times I use ADQL just to keep practicing it. And once you become habitual of ADQL, you don't actually want to use basic because it's too basic, isn't it? So now I'm hoping that you guys learned what ADQL is. Obviously, like you learned very basic ADQL and you can just keep on learning more. You have Google. These days, information is available everywhere. So whatever you like, you can just keep learning it more and more. So you can just choose to just write something else here and just continue with it. Isn't it? And just you can, I mean, there are more sections here which come about. You can start learning SQL for this. This is very basic. The condition that you put, the more things that you can do in this query is that you can group certain things. And one of the most important thing that you can do here, which is impossible to do in like your basic query, is something which I will explain now. So like listen very carefully. It's not written in the notebook that I have shared. It's not there in the screen right now. It is just something which I am speaking, which I just remembered. So like if you miss something because of something, just like let me know, I'll speak it again. These are the columns. The columns that we produce are the columns which are available in this particular database. Are we clear till here? Anyone has any doubt till here? Okay. What if you want the column which is not there in this database, but mathematically in the given columns? For example, well, we saw that distance is inverse of parallax, right? What if you want a column with specific and not like and not parallax? What will you do in that case? So this is where oh, is it still lagging? I'm not moving anything in my like in my screen right now. And the video might be due to internet issues, but just focus on the voice. If the voice is clear, that's like I guess it's good to go. So about SQL, the advantage that which SQL gives you is that in SQL allows you to create an additional column of your choice that you don't have using mathematical operations in the columns which are already present. For example, it's like very easy for you to add another column. Okay, I'll repeat. Voice and all is fine, right?
Yeah, voice is fine.
Internet is okay. I'll repeat. So, there are certain columns which are not there in the database, but with the columns can be obtained by doing some mathematical operations on the columns which are already there in the database. Like for example, if you want to find radial distance is 1 by parallax. You have a column for parallax, but you don't have any column for distance. In that case, what can you do? In that case, what you can do is that the advantage which SQL gives you is that you can not just have columns, you can have mathematical operation on columns. Like for example, in the query that I have written, I can just add another line. Yeah, in this select statement, I can just add another line, which will be 1 by GAIA, 1 by Gaia underscore source dot parallax. And there's this another keyword that I will tell you. It's called as distance. Now what? As let's say dist. So what did it? Another column, and that column is inverse of one of the columns which is already there, and I have named column distance dist. And now if I submit my query, I got another output, and now if I visualize this query, as you can see on your screen, now if I visualize this query, I have an additional column here, which is known as dist. This is what I named that column, and it has like the distances. It is inverse of parallax. I hope my screen is not lagging at least.
Your screen has some lag.
Oh, okay, so I'll just wait for a while here. Just let me know when you see the table.
Yeah, the table is visible now.
I'll switch off my video actually. Maybe that will help. Okay. So now you can see I have an additional column which specifies the distance. So this is something which you can do. You can add columns, you can subtract columns, and one another advantage that SQL gives you is that you can write stuff like there are some functions for finding maximum of a row. You can write max of a particular row, min of a row, mean, median, mode. You can do all the statistics with SQL. There are functions in SQL for doing that. You can find average. You can count the number of objects which are there with a condition. So this is an advantage that this particular thing gives you, which is not there with in basic search. You cannot do this. That's why I prefer ADQL usually. So my runtime got disconnected because I spent a lot of time on that. So I'll just reconnect my runtime and then look for. So you have an assignment after this where you have to use ADQL and plot whatever is there. I mean, the whatever is mentioned is written there. And in this assignment, you actually have to create a new column. I mean that you can, if you want, you can just write this in Python as well, or else it's better if you, I mean, if you want to learn, you can write this in ADQL, where you create a new column with absolute G band magnitude. And what the value of this will be photon G mean magnitude plus 5 plus 5. Now you can use this particular formula. So this is where we are done with Gaia. Any doubts till now? I'm not getting any response. So I don't know if there's no there's no doubt if someone is typing something. Speak out if there's any doubt right now. Or if you don't have, just let me know. Great. I got no doubts. So I'll just believe that there are no doubts and I will continue. So now we'll continue the next archive. We are done with Gaia. The next archive is specifically for Exoplanet. It's called NASA Exoplanet Archive. And NASA Exoplanet Archive is not difficult once you have learned Gaia. Gaia is the more difficult one, to be honest, because you do not have anything new to learn. You can just search for NASA Exoplanet Archive and you can go to this archive. Here you can go to data. In data, where was that? Yeah, confirmed planets. There, here you can click to planetary systems. NASA Exoplanet Archive, the table in NASA Exoplanet Archive looks much better. So NASA, this is the table. This table has all the columns which are there. In the archive, it has lots of columns and lots of rows. It has information about all the exoplanets. These are the ones which have been confirmed to be planets. There have been candidates as well. So what do you get? I mean, you can just read about it. You get a planet name. This is how planets have been named. And does anyone remember the nomenclature of planets that we studied about in the last session? 14 Her B. What does this signify? Anyone? Her B, anyone? What does it signify? Nomenclature of the planet that we studied about in the last session.
Exoplanet, super Earths, gas giants, Neptune-like.
No, that is fine. That is fine. That are the classification of planets. I am asking, The name of the planet 14 HERB. What does like this signify? Yeah, someone said it's the first planet. This is what I wanted to ask.
Yes. Okay.
Yeah, first planet from the host, name of the host. So you have like the name of the planet, name of the host, and some parameters, number of stars in that particular system. Remember, we went on one of the trips where we saw two shadows, two stars. So there are systems with binary star, there are systems with three stars as well, with three shadows. And even there are systems with more stars as well, where you literally feel like you're standing in a cricket stadium with all the floodlights on and you are getting like multiple shadows. And then this also tells you the method by which a particular planet was discovered, radial velocity, and when was it discovered, which facility discovered this. These are all ground-based facilities. And also the most important thing is whenever you're doing science from an archive, you should, whenever you're doing science, you also mention the reference, right? So it is mentioned that in which paper has it been mentioned, like the parameters of this planet and the parameters, orbital period, and there are lots of stuff you can just read about. I'm just waiting a bit because as someone said, my screen is lagging, so I'm just waiting for my screen to be there where I am right now. So these are the parameters which you can read about. What you can do here is that again you can like there's a select column option that you can see in the top left corner of your screen, and you can select what all columns do you want. There are lots of columns again, and you might not want all the columns. You might want column just whatever you need. So it's for you to just choose whatever columns you want. Planet name, host name, planet ID, and these are lots of columns and some additional data. Do you want photometry data? Whatever you want, you can choose it. And after this, I guess there was something else as well. One advantage that this gives you is that you can plot the table directly. Like NASA Exoplanet Archive gives you this advantage that you don't need to go to Python to plot it. I mean, obviously you'll have to go to Python just to understand how plotting is done. But yeah, in general, you can plot all the columns, you can plot everything just using like in this archive. If you just want to see something, you don't need to go there. And then again, you can download table in various formats. This does not give, we tried a lot, but I couldn't find like an option to download in a FITS format. But like a CSV is there, so like no issues. You all know how to read a CSV file, right? In Python? Okay.
Yeah.
Okay. And like here are some tools that you can use. It's not just about this table. This archive has a lot more stuff, and I will encourage you to just go through this and you will learn a lot about periodograms and everything. There are lots of stuff which are there. And ultimately you download the table that you need from whatever options that you want. And once you have a particular CSV file, then you can upload your CSV file and you can start doing whatever science you want to. And yeah, obviously I forgot to mention, yeah, you can also mention the constraints that you want. Wait, let's go ahead. And you can see in these tables, like there are these boxes, empty boxes, right? So you can just type whatever you want. Let's say in discovery method, I type transit. And then I can type transit, and then like it is retrieving the record of. So these are just the transit planets that we have found. Something interesting that you will notice is that all the transit planets ka discovery year is like very recent, 2020, 2021, and some are 2008 as well, but most of them are very recent. But the in a radial velocity method, like the planets are found very like earlier. Secondly, also the discovery facility is transiting exoplanet, like it's the test satellite that we saw. These are the satellites, TESS K2. These are satellites which are the space-based missions. But earlier we saw ground-based missions for radial velocity. So these are things that you can just notice. So this can help you filter out whatever you want and whatever you don't want. And once you download this, then let's see how do you do science from this. Again, just like previous example, I am reading my table from pandas. And just keep doing like you have this notebook opened in your like screen right now because I have shared it. So just keep, how do you start like, run your code by shift plus enter. So keep running your code. If you have downloaded it, if you haven't, you can just see. So yeah, I'm reading my file here and I'm seeing how does my data look like in pandas. Again, it looks very good, like in a proper tabular format. It doesn't look like a random array. And then I can start doing some maths with it. Although this does not look like, for example, I have plotted like these two columns. What are these two columns? Orbital period, I am guessing, and RADE. Okay, Earth radius. Yeah, RADE. I mean, you can even change the name of the columns. One interesting thing that you will notice is that the x-axis which I have plotted, uh, it is in logarithmic format. Because when the range is too much, no, you can't just keep on like plotting it at every point. That's why it looks all very like close. So that's why it's in logarithmic plot. As in the x-axis will look like it will look something uh, radius of 0, then 10, then 100. This is how it will look like. Cause in it's in log. And just to visualize the relation to orbital period and radius. This is how it looks like. This is just for you to like see how a database is. I mean, this plot does not have any importance as of now, but maybe you can find some importance later on. I mean, you still see a trend, right? In this orbital radius period versus radius, how this looks like. So these are things that you can actually do from your plot. And this was just an example of how you can use these two databases to get your data. And as I said, there are a lot more databases. We have just used these two, and you can do any science that you want from these two. And then you have an assignment which you can just use. It's not control plus enter, it's shift plus enter. It said PD is not defined because in the first part of the code, you might not have imported this file. Where I imported this, no, import pandas as PD. So you need to run all these things. You cannot run a section of a code directly. Like there's nothing called as PD or NP. These are just letters. These letters get meaning only when you like write this line. That's why. Anyways, so till now we saw two archives, two databases. There are a lot many more databases which are available, and we have not actually seen how to use data from a particular database yet. The plots that we saw was just something to show you that we can do something from the data. Data is not just a bunch of numbers out there. So that's what we will see in the other part of the session. And we will have a 10-minute break, just like our last session. We will meet at 12 again to actually see what this session was all about. We'll get into artificial intelligence and machine learning. Sounds really cool, isn't it? That's what we will get into now. I am hoping you guys are really excited for this. So you can just take a break, leave the meet if you want to. You can, but join on time because I am not going to wait. Because this session like got extended a bit. Similarly, the other part might also take same time, so it might be a bit lengthy. I mean, not as lengthy as this one, but still might be. So just be on time. We are not going to wait for anyone. If you want, you can just stay here. Meanwhile, in 10 minutes, if you have anything to speak, if you have any doubts, feel free to just let me know. Stop sharing. Hello and welcome everyone to this session again. It's 12, so we can get started with the second part of the session. I'm hoping all of you are here and no one left. If someone left, uh, please call. Can one of you just put the message in the WhatsApp group if like someone left, they can join again or something. Because now we'll get started with the ML part. Before starting, I just want a raise of hands as to how many of you have done something related to ML in the past. Okay, at least there is someone who has done something related to ML in the past. And how many people are there who have never heard of the term ML? Yeah, Srijan, I know you have done ML. You have prepared the slides and everything, so you've obviously done ML. You did ML last night only. Is there someone who have like was never heard of the term ML or AI? Okay, so at least you guys are aware of what's going on in the present world, what the updates that are going on in the present world, and I'm hoping that most of you would have at least used Chat GPT at some point in their lives. Is there someone who doesn't know about Chat GPT yet? Because I was very surprised to know when like one of my friends told me that she never heard about Chat GPT. Just before starting, once I'm checking if I'm audible.
Yeah, you are audible.
Great. I'll just share my screen, it is still recording. And from your responses, I can get an idea that at least all of you, some of you have done ML, all of you have heard of the word ML and AI, and you have some idea about it. So that's like really good to know. But still, let's get started with like doing ML. Okay, I'm presenting my screen now. Machine learning. So now it's time for a few responses. What do you think machine learning could mean? Like we all know what it does and everything, like people who have studied it or who have heard about it, but just from what could the term mean, machine learning? Few responses now. You can speak up. It takes less time than typing. Someone has written learning from the set of data. Does machine learning like need to have data? What does the term machine learning simply means? Do we have more responses coming up? Okay, so machine learning, as the term suggests, yeah, it's very cool to use the phrase as the term suggests. It's about we all know what human learning, right? We have been doing human learning ever since we were born. How do we do human learning? We have seen like the things that have happened in our surrounding. We have, I mean, that's how we have learned anything. We have observed and we have tried to replicate. And once we have tried to replicate, we have learned a process, and then we have tried to, create something on our own. Also from our parents. So like how we have learned from our parents, our parents have showed us how to do things. We tried doing that. We tried replicating that. We made mistakes. I'm pretty sure there is no one like in this chat box or in this entire world who hasn't made a mistake yet. So we have made mistakes. We have all had our errors, and our parents have like taught us sometimes in a polite manner, sometimes in a violent manner, particularly if you are an Indian. And like in whatever way they taught us, end of the day we ended up learning it. So that was all human learning was about. And we went to schools, and then we got in more and more data, and we learned about it. We formed our opinions from that data, and like from whatever we saw, learned, we formed our opinions, and we used those opinions to predict whatever is going to happen. Now, this is an exact, you can create an exact analogy of this to machine learning as well. What does machine learning mean? Machine is learning something. Machine is learning something to do something by itself. How is it learning? So the learning process takes 3 steps. The first step is like accepting the data that is given to the machine. Second step is understanding the data, what the data is about, what the data is trying to predict, and by understanding, also creating a well, what does it mean by understanding data? Understanding a data means creating a model out of a data. It means creating a function out of a data, like in very simple terms. You all know what mathematical definition of function is, right? A function consists of an independent variable and parameters. That is all a function consists, and some constants. But let's just ignore constants for now. But in general, we can say constants, mathematical operations. But function consists of uh, a set of parameters and one or more independent variables. Now, the mathematical definition of function is given by something which takes in input and gives out an output. So what is mean by understanding a data? Understanding a data in a very naive way can be said to be getting in the data and creating a function out using that data. So once that function is created, the third step comes in, which is predicting something from that data. So once the function is ready, you can just use the same function, get in the value of an independent variable, and get something out of it. So ML to a physicist, to be honest, is more like curve fitting. Although it's just a part of ML, but that's how physicists usually think. Is there any physicist in this chat? In this group? Anyone from physics department, learning physics, doing physics? Of course. Yeah. So according to physicists, they say ML is just a fancy word for fitting. But there are more stuff in it. Let's get started now. Some things about ML that we all should know before actually doing ML, because if I just open that Jupyter notebook and make you do ML, it won't help, because I mean, you will just run the code and you won't understand anything. So I thought it's important to know a little bit about it. So what is machine learning? As the slide says, machine learning is just computer learning from data from past experiences, as like I talked about till now. Is a machine learning model. I explained to you all what machine learning function is, right? Oh, hey, can someone just confirm if the recording is still on?
Yeah, it is on. It says it's recording.
Okay. Okay. Yeah. So what exactly is a machine learning model? Our function, our job in machine learning is to take in it and create a model out of it so that we can use that model to predict something. Now, what we live in a model-based universe, by the way. Everything that you have studied till now, no one knows what the truth is. Be it in physics, be it general theory of relativity, special relativity, be in chemistry, be it your any of the chemical theories that you must have studied. I forgot the names of all the theories that I learned 11th and 12th, but any theory that you have seen, it's just a model, and it's just used to like describe the real life, but no one knows, to be honest, what exactly real life works. So everything is a model that you see. When one model fails, we give a new model to describe the universe in a more better way. So that's what a job of the machine learning is, to create a model. And like for example, as you can see in the plot, what this model, what like but this particular machine learning algorithm is doing is it is grouping, or known as classification, but we'll go there later on. This model is like grouping stuff, so that if you give it an input, it will realize in which group that particular input will lie. Again, just keep on asking doubts if you have. Now coming machine learning. So when you say machine learning, it usually feels like hi, am I back in the meeting? Somehow I had to leave. Yeah, I'm sorry, but somehow things happened with my internet and I had to leave. Is it audible now?
Yeah, yeah.
Okay, great. Yeah, I'm really sorry, guys, for like today. Like, I know it's really unfair to you all, and it's even not nice for the people who are actually teaching stuff. Yeah. So we were discussing about the types of machine learning model. So what when we say we are yeah, thanks for reminding me. The last word was machine learning is. When we say machine learning, what I told you, we are trying to learn what that to do with the data by telling it that this is the input, this is the, and now using these inputs and outputs, you have to create a model so that when you should be able to give me a good output, isn't it? This concept about machine learning. Give that particular model an input as well as an output, and it learns from input and output, and it creates a model. Once that model is created, we can give it an unknown input and it will give us an output. Any doubts like till here? Yes, yes, no, yes, no. Someone else designing algorithm will set up. Yeah, during the designing of an algorithm, yeah, it's one way to put it. We like gave it both input and output. I mean, like as an analogy, you can think of it in this way that during human learning, when you're trying to learn something, when you're somebody trying to show you something, they show you how the what do you do and what do you get out of it. They show you both, right? Or for example, when I'm teaching you this particular session, when I was in the Jupyter notebook that before, what did I do? I sent you the notebook. I showed you the input, whatever the code I'm writing. I saw the code and I showed you the output, right? And from both the input and output, you learned like whatever, right? You get both input and output at the same. Yes. Yes. Just let me know if you haven't understood. I can just like go through it again with a even better example. Oh my God, it's not audible. Is it
Very
audible now?
unheard.
Is it audible now?
Yeah, now it is audible.
Okay. And then he said, yeah, like it's not. Uh, Let me know. You can like if it's not audible, probably later, so I won't be able to see the chat box as well. So you can just go. WhatsApp is still visible. Yeah. So what I was telling is, have you understood till now the concept wherein you give it both initially for the model to evolve in a way to like create something out of it, and it has created that model, then you just need to give it some unknown input and it will give you an output. Have you understood this much? Yes. Okay. Someone is answering. Good. It's better to keep session interactive, otherwise it gets too boring. Okay. But like, what I wanted to machine learning is tell you specifically that this is the input, this is the output, this is what you have to do. The mentioned before, when you give both input and output, when you specify everything, when you like, fit it. The second point on your screen. And there's an unsupervised learning as well. Learning means that you don't have a machine, you just like take data and it's like ML algorithm to protect the data. It depends on itself. And then there is reinforcement learning, which is coming new. Reinforcement learning, what you do is you define something called reward function. That if or it is intended to do uh, uh, reward of it, and if it isn't, or there is a different concept altogether. For one, for supervised learning, something like has the slide changed? I have changed my slide like
No, it's not changed.
The slide I'm
is
seeing is types of machine learning. Can you confirm?
no. I have moved to the next slide.
Okay.
I mean, I'm doing the best I can. I'm using my mobile data literally because it's still and it's not working. Okay, someone said audible too. Am I audible now? Uh, I don't think I can do that right. Okay, to be start with, am I audible?
Yeah, you are
You're audible.
audible, but at sometimes it is lagging.
Yeah, I mean the internet. I don't know why is it behaving like this. It just keeps working. But you're still seeing the same slide, right? The slide hasn't changed for you.
No, the slide hasn't changed.
Oh, types of machine learning only, right?
Yeah, yeah.
Maybe I'll sharing my screen again because I have been changing slides. Stop sharing. and then share again. Here in this happens. Okay, is my screen visible?
Not for me.
Yeah, it is not visible.
It is shown that you have shared a screen, but it's blank right now. So I guess.
Can I share the screen and you can speak?
Yeah, I think that will be better because it is somehow it's not gonna work. ठीक है, you are there in the PPT, right?
Yeah, I'm having the PPT.
Sharing.
Okay, so I'm sharing the PPT right now.
Okay, cool. You want me to share? Maybe if I use it, it will work any better. Okay, yeah, I can see your screen. You are in the last slide actually. Can you go back to the types of machine learning slide? No, I'm still seeing the same slide. Is it just me?
Even I'm seeing the same slide.
Okay, okay.
Now I have changed the slide.
Now it has changed. Do one thing, like present like full screen if you want, but this much is also enough. Good enough. Wait, huh? Go before this slide to. Yeah. Okay. So I just need to well now, and I'm hoping that I am because I'm only connected to one device now and just one system. For one final time, can someone confirm if I'm audible clearly? Okay, I got a thumbs up, so I'm audible. So types of machine learning algorithm. What we learned here is we saw about the types where you deliberately tell your ML algorithm that this is your input and this is your output. If you write it in terms of y is equal to f of x, you tell your machine learning algorithm that this is y and this is x. This is known as supervised learning. What is unsupervised learning though? Unsupervised learning is the ML algorithm where you don't tell your machine anything, this is y and this is x. You just give data to your machine and you just learn it and do whatever it wants to do with algorithm. This is known as unsupervised learning. And reinforcement learning is something very new in ML. In reinforcement learning, you define something called as cost function. It's either cost function or reward function, wherein it gets positive like it does the job it intended to, and it gets negative points if it doesn't. That's what the types of machine learning algorithm. Like these are the various types of ML algorithm. And okay, to some of you who might be confused between, do you know the difference between when the people generally tend to use AI and ML together? Do you know the like the relation between AI and ML? Does anyone? Because usually it's said AI ML AI ML AI ML. Yeah, as someone said, AI ML is a sub part of AI. So AI is this entire field of artificial intelligence where what we are doing is that till now we knew about human intelligence, we know about that we are intelligent and how all these things work. But like in artificial intelligence, we are trying to create an intelligent machine. The perfect example in these days is ChatGPT, which is like an like AI tool. And machine learning, where you are making machine learn something out of it. And there are various other things that like can be a part of AI. So the issue is with defining, as Naveen has defined, ML is teaching machine to do work like human. The issue with this definition is that it only involves supervised learning. That's what I want. That's why I said this in this slide. This is the issue with this particular. So the unsupervised learning is also part of machine learning. It just uh, telling machine deliberately what to do. Anjali, you can move to the next slide. Okay. Okay. Somehow in my screen it's still showing the previous slide. Again, might be because of my connection. Yeah. So which slide are we in regression versus classification slide?
Yeah.
Assume like we are there. So we were so understanding the can is when you particularly into
Your voice is not clear.
good. Okay, hi, I have rejoined now. And I just hope it remains fine this time. Okay, so regression versus classification. So regression is more like creating a function wherein you have an input and an output, and your job is to I mean, the machine learning algorithm's job is to create a function wherein you can ask a question. You can like ask you to predict something. You will give it an input and it will tell you that if this is the input, that particular thing will be the output. Like for example, as you can see, like the question that is being asked, what will be the temperature tomorrow? This is what regression does. The other task that an ML algorithm does is called classification, where it classifies a certain input into like various categories. An example could be one of the example is you can see on your screen, like you can ask it if it's like hot or cold. It just classifies data in two different buckets. Or like another example could be you can just give a picture to an ML algorithm and ask him if that picture is of a cat or a dog, and it will classify it as cats or dogs. So these are the two major tasks that ML algorithm does. There is another task known as clustering, which comes in unsupervised learning. But yeah, let's just be since we are starting, let's just focus on very simple things. So init out till regression versus classification. This is very important. If you don't get this, you won't get anything that we will do after this. If you like keep on saying yes, no, it also helps me know that I am actually audible. Because otherwise I don't realize at times if I'm speaking or if I'm still there in the meet or not. Okay, if no doubt, then we can move to the next slide. Okay. Some of the important definitions that you should know and focus on, because you will be using this definition in the code file. So test, train and validation data. You have this entire bunch of data. Some of the data is known data, as in you know both the input and the output, and some of the data is like unknown data for which you know the input but you don't know the output. The data for which you know the input output is used to train the model. Now, what is meant by training the model? Training the model means giving it both input and output and asking it to create a model, as I said before. And once that model is created, that's when you start testing your data. What does testing mean? Testing means that giving a new data, an unknown data, and asking it to predict something. Like for example, in terms of classification, you can give it like 100 pictures of cats and dogs and tell them that this picture is of a cat, this picture is of a dog. This is called training an algorithm. And by doing this, that algorithm, like it will create a model. And once that model is created, you will give it a new picture, a different picture, and then it will classify this picture in cat or dog. It will like put it in either of the buckets. This is called testing and training. Now there is another term that you see, validation data. What is validation data now? Validation data is actually a dummy test data. What does it mean? The trained data that you have, which has both input and output, you split that data into two parts. A bigger part, usually it's the bigger part which you use for training the model, as in you have both input and output, but you know very secretly you just keep some data with yourself. Some data for which you have both input and output available. You keep it with yourself, and what do you do once like that model has trained itself and created a complete model out of it? You give it the validation data that you have, the validation input that you have, and you don't give it like the output. You just give it the input, and you see what the output is. Now you match the output given by that model to the output that you already have to see if the model, whatever model is created, is like how right that model is, how correct that model is, to validate that model. Because if we are giving it an unknown data, if we don't know the answer to it, we will just accept whatever the ML algorithm says, right? But we need to be sure if it is saying right or wrong. For that, we use validation data. So I hope it's clear like what test, train, and validation means. Okay, great. Next slide. Can we move to the next slide? Yeah, great. Still can't see the next slide. Okay, now I can. Just a question for you all. How many of you are from IITM? As in from IIT, and as in like in campus, as in like offline students of IIT. Can I get a few hands up? No one's from IIT. Okay, obviously, huh? Like, how many of you attendees are from IIT? Oh, okay, no hands up. So I'm hoping like none of you are from like campus. You are very lucky because you have good internet. Campus internet sucks. Yeah. So someone now coming to some of the common terminologies. Now the data that you have is you just saw the table. I have been talking about inputs and outputs till now, but that's not the term that you use in ML. The term that you use is features and targets. What are features? The inputs that I mentioned are called as features. Features consist of multiple columns usually, and targets are the output column, whatever output you want to produce. Output could be anything, like for if you're classifying an exoplanet, if you're saying if something is an exoplanet or not, then output would be its status, if it is a candidate or a confirmed planet. Input could be anything that you see, detection method, it's array deck, whatever it can be the input. Now, third definition is cost function. What is a cost function? Cost function is used to remember how I said how your parents, like teach you, and how are your parents usually scold you as well at times. Might have beaten some of you as well, like when you're learning something. We can remain in the previous slide, Anjali. Yeah. So that is what cost function is about. Cost function, as I said, you have some validation data. Validation data helps you tell which, if like your ML model, the output that your ML model is giving, is it like right or wrong? So that's where your cost function comes into play. It tells us the error in the model. Like you need to quantify an error, how much the error is. So there are various ways by which you do. You can use a mean squared error, for example. In statistics, you must have learned these terms. So these are cost function. Now, there are two more terms. It's called underfitting and overfitting. As the term suggests, overfitting means that you are like, like the ML algorithm is fitting more than it's supposed to the data. What it means is that when you're giving it some data to train itself, what it does is it creates a model which like particularly, which that model is not a generic model. That model is particularly for that particular training data that you have given it. It is possible that our data could be biased, right? Like it is possible that I could give an ML algorithm, for example, to train all the data that has just confirmed exoplanets. Now, if I do this, there is an option for my model to for my ML algorithm to create a model which says that irrespective of the input, the output will always be this thing will confirm exoplanets. But in my testing data, there might be a candidate, there might be a false positive, there might be a planet which might not be an actual exoplanet, but my model will still say it is an exoplanet. But what? Because it has learned a bit too much from like its uh, input data that we gave it to train. An example of this, an analogy of this in human mind and human thinking is called as overthinking. That all of us have done at some point, and all of us usually do every day and every night. Overfitting is analogous to overthinking that we all do a lot. So, which is not good. And then coming to underfitting, just like overfitting, underfitting is the opposite of it. It is when the model like cannot actually understand what that particular data is, and it does not like create a particular model out of from the given data. So that's what underfitting is. And this is very important to help you know that you need to change some parameters, or you need to change, switch to a different algorithm to create something. Yeah, next slide. And these are some of the machine learning models. We will not go into the details of what these models mean: linear regression, random forest classifier, k nearest neighbor, support vector machines. I just hope that all of you at least know what linear regression is. Must have done at some point linear regression. Anyone here who does not know what linear regression means? It is like the first machine learning model that we see. Okay, it's okay. You can just tell if you don't know. It's okay to not know. And it's good to ask if you don't know rather than just ignoring. The background does not matter. Linear regression simply means that whatever model that you are trying to fit a straight line to that model. Fitting a straight line means that the function that you are trying to create is like f of x equal to ax plus b of that particular form. So that this is an equation of a line, right? Y is equal to mx plus c, or fx is equal to ax plus b, isn't it? So you are trying to just find out what a and b are, and you are trying to create a line, and that line will predict. This is known as linear regression. It is like the simplest and one of this is how ML starts. Like this is the algorithm which is used for that, and other like names which we need not go into detail to. And Ajay, you can move to the next slide. And these are the applications of ML. When we'll share the slides, you can read about the applications. Since like we've already taken lots of time, let's just move ahead. Next slide. And machine learning, the use of machine learning in astronomy. Again, you can read this. There are multiple uses. We will like actually show you practically how to use one of it. We'll do exoplanet detection using machine learning, which is the more important part. So next slide.
Slides are done.
Okay, we are done with the slides. So I think, do you have access to the notebook?
Shall I share the notebook?
Yeah, sure. If you Anjali doesn't have, Shrijan can share the notebook. Okay, yeah. Also, before sharing, I'll do one more thing. Or yeah, this I will do. I can do at least this much. Share it with you guys on WhatsApp. This notebook. Okay, Shrijan, I can see your screen, but before that, I'll just share this notebook with these guys so that they can do this in real time. Again, is there someone who's not in the WhatsApp group? I have shared this particular notebook in the WhatsApp group. Please open it again and like open it in your, upload it to your collab and see so that you can start using. Once you have done this, give me send me a thumbs up or something, anything, a message or something, so that I know that you have done it. Have you received the notebook that I have sent? Pretty sure at least I sent it.
Yeah, that's fine.
Oh.
Yes.
Okay. So upload it in your collab. I should have done it before. It's start. Have you done it? Just go to file and just like open and upload the notebook. Okay. Like since one of you have done it, I'm assuming that like enough time for you to do it. And now let's get started. So as you can see in your notebook, usually like as usual, we start with importing important libraries. We have imported pandas, numpy, which is very usual, and then matplotlib, and then cbon. What is cbon? I'm pretty sure you must have not studied about cbon before. Just like matplotlib, cbon is another library which is used for plotting. And now after this, you see some interesting things happen. I mean, you see, we have imported a few more libraries, which we didn't do before, right? So for doing machine learning, the library that we used is called as sklearn. It's called scikit-learn, and sklearn is the code word for it. And going through one by one, like for each of the code line that has been written. So the first line from sklearn.linear model, we are importing logistic regression. Logistic regression is a machine learning algorithm used for classification. So this gives you an idea that in this particular project, we are going to classify. Second one is model selection when inputting test train split. How does this help? The entire data that we have, it helps us to split our entire data into two parts. One part we can use for training our model to create a model, and the next part we can use for testing our model to see like how good that particular model is. And then from sklearn ensemble, we are importing a random forest classifier, again a classifier model. Now from sklearn, we are importing metrics. What are metrics? Yeah, hi. What all are we using? We are using a mean squared error. We are using a precision score, confusion matrix, and accuracy score. See what all these things individually are that you can like keep on seeing. You can Google it what this means. At least I hope you know what mean squared error is. You find the squared error, you find the mean error. That gives you one number that helps you tell that okay, if is the error increasing or decreasing. So other definitions you can just Google up it. For now, you can just assume that all these metrics gives you a number which helps you judge if your algorithm is working nicely or not. And again, keep on asking if you have any doubts. Next part, what we'll do is we will import data that we have done till now. We have our data stored in exoplanet.csv file. You can input data from the two databases that we saw. This we have imported, I guess, from NASA Exoplanet archive. And then we can see how our data is looking like. Yeah. So this is how the data is looking like. We have like names of columns and the rows. The interesting thing is you can change the names of columns if you don't like. As you can see on your screen, we have a data of 9,500 rows. And then some 19 columns that we have. At times, we don't need all these columns. So we have an option to choose whichever columns we need. But like we have already went through all this before, so no need to go through this again. So once the data is open, the next step would be to get some information about data. For doing machine learning, you need to have some information about the data. The basic information that we need to have is that what kind of like data is present in each column. As you can see, the data type tells us what kind of it is, like if it's a float or if it's an integer or things like it. And another, you can just go to the like before the blog before this, the one which we were showing. You can see a central column, right? The central column shows like the central column shows this one dl.info. In the central column, there it shows non-null and count. As we saw in our database before, there are some data which are not available to us. So there are some null values. So this all helps us know that how many null values are there and how many of the points we actually have original data. Because one thing that I should mention here is that machine learning algorithms are not very good at handling null values or NaN values, which are usually there. So one part of it is, which I guess we have done later on. Okay, we'll see when we go there. Next, we have like some of the plots just to visualize the data that we have. We already have. Let's just like continue with it. Like we have already seen how plotting and everything is done. So let's just continue with it. And then see it in the slides. Now what are we creating? We are creating. Okay. Another very interesting thing that you should know is when you're doing ML, certain columns have outputs in terms of words, right? I mean, you might have seen certain columns had stuff like confirmed, not confirmed. It wasn't any number, but it was like certain strings. like candidate confirmed and stuff like that. But ML algorithms are mathematical algorithms, and mathematics usually works with numbers. It does not works with like letters and all. So your input and output is usually like preferred if it's in a numerical format. So this process is known as encoding. What we do is that we encode these words with a particular number. So what we have done here is that we have encoded confirmed with 1 and candidate with 0. So every part of the our table which had confirmed written is changed to 1, and which had candidate written is changed to 0. And so we have defined a new column. Now this is very important because this is the column that will go inside the algorithm to like let the machine learning algorithm work and understand what that is. Because however smart algorithm it is not AI, it is just ML. It does not know what words mean. For that you will have to study NLP, natural language processing. But anyways, it's something different. Now the next part of it is, as I said before, once you have the data set, it's very important for you to keep to clean that data set too. Because if you don't clean it, it won't work. Because as I said, machine learning is not good with nan values, and there are certain columns which have some random values which are not physical. So what happens is that it won't understand. ML algorithm is like a little kid who has just being born. They don't have the capacity to understand what is like not possible. For example, can you, for some of you give me one value which would be impossible of something? Let's say, for example, radius. What is one radius value which is impossible? No planet can have a particular what radius values? Physically impossible.
An imaginary number.
Sure, but more simpler would be a negative number.
Imaginary number.
Yeah, imaginary as well, but a negative number is a more simpler value, which is not possible. But your table can still have some negative numbers because of some reason, some issue. Now for machine learning does not at all know what physics is about. It does not know that it is representing, that row is representing something which should not have negative numbers. For it, it is just a matrix filled with numbers. So it is for us to like, filter out all those rows to make sure that we are not giving it any input numbers, because if we give it, it will consider it as a right input, and the model it will create will be based on that particular input. So obviously uh, if it is wrong, then like our model created will be wrong. Or if like, you see bad stuff happening in your surrounding, you grow up being that person. Yeah, let's not go there. Huh. So basically, that's why you need to clean data and clean your soul too. So once you like clean it, now you have all the columns consisting of all the numbers which are right, which does not have some things which should not be there. And you have also encoded all the like letters or the words that you need to certain numbers. As you can see, 1 and 0. 1 and 0 are binary numbers. That's how you encode it. It's up to you. You can encode it as 5 or 0 as well, or you can 1 minus 1 as well. It's up to you. But this is how we have encoded it for the ML algorithm to learn. Now, you can just go through individual part of the code and understand how it works. I am not going through that I'm just telling you what the section of code is doing, and you can just spend some of your time in Python to understand this. If not, you can just ask me this personally and I will like let you know. I just don't want to extend this session a lot. And you can go to the next part after cleaning. Now, what are we? I mean, we have already cleaned it. Our next function is to define the function which will evaluate the data that like we had. Because as I keep saying before, like we imported certain metrics before, like mean squared error, precision and stuff like that, right? So somehow we need to, have something which tells us how good our model is. So we are defining a function. I hope you know how to define a function in Python. This function takes in two inputs, y_true and y_pred. Y_true is the actual true values that we already know. Now this is what we do with validation data. We already know the true outputs, but we don't tell this to the ML algorithm. We just tell it that it is an unknown data. So what we do is that we give input to the algorithm. It predicts some values, and we already have the true values. We give these two as input, and then this function that we have defined evaluation. It gives us accuracy and precision and recall values. What precision and recall are, that you can again study what these means. Just for now, you can just understand that these are a few metrics that helps us know how good our algorithm is working. So this is what it does, and then we have a confusion matrix. Confusion matrix tells us how many of them are true negatives, false positives, false negatives, and true positives. There are these four terms. These are very important terms in ML. True negatives, false positives. Now the negative and positive stands for the output that our machine learning algorithm gives. Positive means that machine learning algorithm says that this particular object is an exoplanet. And the negatives mean that the ML algorithm says that this particular object is not an exoplanet. It either will say it is an exoplanet, or it will say it isn't an exoplanet. And the true or false means that, I mean, it assumes that you already know the answer if something is an exoplanet or something isn't. So given that you know what true and false means and what negative and positive means, I need one of you to tell me what will false positive mean. Just combine the two things that I said and tell me, one of you, what does false positive means? Anyone? I will repeat. True means yeah, as someone said, false positive means that the model has said it's positive. That means the model has said that it is an exoplanet, but in reality, we know that it isn't. Now, if you know what false positive is, you can automatically understand what's true positive, false negative, and true negative is. So a combination of all these, like we create a matrix out of it, and it is called as confusion matrix, which it also gives us an idea of how good an algorithm is working. We want more and more. We want okay. Another question to you would be, if a model has higher false negatives, is it a good model or a bad model? If the amount of false negatives are like very high. I have some answers. Yeah, Siddha. So it's actually, I have two answers, like good or bad. Obviously, these are only two possibilities. Like for some of you who have not understood this question, I'll repeat it again. What are false negatives? False negatives means that we know that, uh, false means we know that this particular object is not an exoplanet, and the model says it's not an exoplanet. Will that be good or bad? Yeah, it is good. That's all. So having higher false negatives and true positives means that the model is good. And likewise, having higher number of true negatives and false positives means that the model is bad. Basically, the model should tell you the truth. That's what these means. So now we have defined an evaluation matrix, and later on we can, like, tell our model to like see whatever, like if it's like good or bad. Now, what will we do later on? Ultimately, we had a table, right? The table consisted of all the rows and all the columns, as in it had inputs and outputs together. But for giving ML algorithm that input, we need to like specify. We are using the supervised learning here. It's better if I would have asked you this question rather than telling myself. Anyways, so we are using supervised algorithm here. So we are telling this model specifically that this is input, this is output. So as you remember, we in ML we call input as features and output as targets. So we are giving it as what are features? Features are all the all the columns of the table that we have given, except for two columns: exoplanet candidate and exoplanet confirmed. All rest of all we are giving it as input, and the output is like exoplanet candidates. The column exoplanet candidate will be our output. Now we have defined what is input and output will be. What is next to define? The next we have to split out the entire. See, we have limited amount of data. It is 9,000, but it's still like not unlimited. So we have to like split that data into like the number that we will give the model to train and the number that we will hide with ourselves. By the way, the test that we have written here is a misnomer. Usually for testing data, we do not have the output. So the X test and Y test that we usually use here, it's called, it's actually the validation data. The test train split function splits the entire data into test training data and validation data, which is here referred to as test. So just keep this in mind. Test is something for which you do not have the given output. And here we are splitting this particular function given in sklearn. It helps us to split the data into x-train, x-test, y-train, y-test. What are x and y's? X is the input or x is the feature, y is the target. So we have split it. Now, what are we putting? The input are the features, targets, which is the x and y, and random state equal to 1 means that 1 means true and 0 means false by the way in Boolean algebra. So random state 1 means what we are doing is that we have our table in a particular format, right? Once we run this particular code, what it does is it randomly splits it. Like it does not do we are like let's say for example, we are splitting 70% as training data, 30% as validation data. So it's not like it does the top 70% for training and the bottom 30% for validation. It's like it randomizes the table and then it randomly selects 70% for training and 30% for testing. It helps in making sure that we are not overfitting the model. Otherwise, if we do that, then the model won't be good. There is another thing that we usually do. It's called as cross validation. But yeah, let's not go there for now. Now we have our model ready. Sorry, we don't have our model ready. We have our data ready in the format in which we are giving it input. We know that our data is clean and workable. We have split our data into input and output, and we have splitted the test and train data. So now the next job is to actually start training the data. It looks like a very simple straight one-line code here, but a lot of work goes into that. And the bigger your data is, the more time it takes. Here it didn't take much time. So we are using logistic regression, as I said. So how does it? How do we use that? As you can see on your screen. How do we call logistic regression? We are creating an object of the function LR, and now in the next line we are asking it to fit. We are giving it specifically, as you can see, X train and Y train, and it is creating a model. That model is stored in LR. The second line of the code creates the model, and after it stops running, we have our model created. In the third line of the code, we are asking it to predict. We are keeping the actual y values that we have with ourselves, and we are just giving it x values, and it is predicting something which we are storing it in a variable known as ypred. And after that, the evaluation function that we created, that we are using to see how good our prediction is. And the metrics that we created, do you remember the metric that we created, which had accuracy, recall, precision? So it gives, this is the numbers. Now, if these numbers are good or bad, that you can understand only by if you know what accuracy, recall, prediction means. So that is fine. But now we also created a confusion matrix. You have the confusion matrix on your screen right now. So how do you classify this algorithm? You have like the numbers on your screen right now. Would you have the number of true positives, false negatives, false negative, true negatives, false positives, and false negatives and true positives? Yes. Anyone? Okay, no reply. Yeah, it's disappointing to have no replies. Anyway, so if like there are no replies, I can't just stop because the time's extending, so I gotta continue. The ultimate point is that yeah, that is one of the point. There are lots of true negatives, but like true positives are also a lot in number. Oh, I was not
Actually,
audible.
yeah, you are audible, but whatever you described as true negatives and false negatives, they should be interchanged. Like false negatives are what the model incorrectly labels as false. So they are actually true, but the model labels as false. That is what false negatives mean.
Sorry, what? I couldn't hear you clearly. My internet is cupping a lot.
Yeah. So false negative, you said that the actual value is false and the computer, like the model is predicting it as false. But actually it is when the model predicts it incorrectly that it is false. That is what false negative is. So in this true negative being higher means that the model is predicting a lot of negative values as negative rather than it predicting like true values as
All
false.
right, all right. Yeah. I'm sorry. I'm sorry. Yeah. I'm really sorry, guys. What she just said was right. So yeah, this model is actually like good because it has lots of true negatives and true positives. So yeah. Uh, uh, that's not how you classify a model. You don't say if a model is. It's just what I was asking you. The ultimate is you compare between different models. There are lots of ML algorithms. There you use logistic regression and you can use other models as well. Even in LR, you had some parameter that you given as input. You gave C is equal to 100 and max set is equal. So you change these models and you try to find out if changing some things help your model become better. Compare between models, and that's how you say if a model is working better than the previous model. You like there's no absolute definition of good or bad in this. That's what I wanted to say here. Okay, you can move to the next part. Yeah. Here we are done is we are just seeing the test. We are just trying to visualize our test results in pandas data frame. Yeah, go to the next part. Now, last week is regression. We are use a different and see that model is better than the. You can question which is better. Which isn't. So this is random. And we're doing the same thing again, and we are evaluating. And this is the that this model gives. Now it performs better on the given data set. My question is audible.
Yes.
So is when the both models, I mean, given both the models, do you think which model is performing better? It's not difficult to compare. This is the previous model and the next model. Logistic regression for a specifier. Question is audible is what I'm assuming, but I can't see the response. I am audible, right? Of course, this is the best. I mean, you can see it has a better accuracy, precision, recall. It has everything better. So this model works better for this particular data set. So this is what ML was all about. This was an example of how you do machine learning on a particular data set. A simple example, you can do a lot many stuff. And since there are multiple models, some models work better for a particular data set, some doesn't. And you have to like find out which model works better for your data set. So I guess this is
had a
where we come to
question.
the end of our. Sure.
Suppose there was one algorithm that tested upon 1,000 planets and it gave an accuracy of suppose 94%, while there was another that
Okay.
tested on 100,000 planets and gave an accuracy of 88-89%.
Tested or trained?
Uh,
Tested or trained?
trained. Sorry, trained.
Trained. Okay.
And so
Okay.
which one would you say would be a better? Like a higher accuracy, but
okay. First thing
lesser number.
is yeah. Listen to me. Listen to me first. When you're two models, no. One of only way to compare two models is to make inputs to both the models are same. Otherwise, there is no comparison. You can't tell which model is performing better. So when you're comparing, the first thing to make sure is that data is same to both the models. Otherwise, it will be like comparing apples to oranges. Yeah.
Okay, got it.
Any more doubts? Yeah. We come to the end of our entire module in astronomy. In this summer, so we started with exoplanets. We saw the use of data in exoplanets. Then we saw two of the very famous. We saw how do we use that data. So I personally feel when I started this study, I used to study this. I feel do whatever we do. Because we have that and yeah, I already shared the notebook. You can you can just Google and learn more about this. And I'm just hoping that most of you will end up pursuing astronomy and do some data science in astronomy. Yeah, I don't think there's any more to say. This is just ML, and ML and AI has a lot of scope in astronomy. It is still used a lot. Is how I want to put it. So that's the end of our session, and I am I'm Rishabh Srivastav. I am a fifth year undergrad. I would call myself degree in data science, and I. So this session was brought to you by Horizon IITM, which is an astronomy club of IITM. I used to be a club head in this club 2 years ago, and with me are Anjali Mishra and Shrijan Bhatt are both from physics department from 22, right? You guys introduce yourself. And,
Yeah. Hey
it's
guys,
important for them to know the speakers.
I'm from physics department at IITM. I'm gonna enter my sophomore year. That's it.
Yeah, Anjali, your turn.
Yeah, so I'm Anjali Mishra. I'm also from physics department, and I'm there in Horizon Club as a coordinator. Yeah, that's it.
Yeah, so the three of us, we tried to present the work that we could in the best possible way that we can to help you guys understand the maximum. And we hope that you got our goal was to make you learn, make you understand, and we hope that we have succeeded in this. So yeah, I guess, yeah, that's it. So thank you for attending the session, and I will again try to stop the recording just like yesterday. And I hope I should be able to do this today.